We're going to start with something that should not be possible. The universe was already unimaginably large. Then James Webb looked deeper, cleaner, and the numbers didn't just stretch, they slipped. Galaxies appeared where there shouldn't be any. Light arrived that had no business being that organised, that massive, that early. According to our best models, the universe did not have enough time to build what Webb is now calmly recording. And yet, there it is. Not one anomaly, not two, a pattern. We thought we were measuring distance. Instead, we may have stumbled onto the true scale of everything, and it refuses to sit still. We've always measured the universe the way humans measure danger, indirectly, carefully, with proxies. We don't reach out and touch distance. We watch light crawl towards us. Light is our messenger, our witness. Every galaxy we see is not where it is, it's where it was when the light began its journey. When we say something is 10 billion light years away, we're saying, this light started moving before Earth even existed, before continents, before oxygen-rich air, before bones. That delay has always been our comfort. It gave us a buffer, a sense that the universe unfolds slowly, obediently, one structure at a time. First stars, then galaxies, then clusters, then the grand cosmic web stretched across hundreds of millions of light years like frost on glass. James Webb was not built to challenge that story. It was built to sharpen it. Bigger mirror, colder instruments, infrared eyes tuned to ancient light stretched thin by expansion. Webb's job was simple: look back further than Hubble, resolve earlier chapters, fill in missing pages. Instead, it walked straight into the margins and found fully written paragraphs. When Webb pointed toward what should have been the cosmic dawn, it didn't see chaos. It didn't see half-formed clumps struggling to ignite. It saw galaxies. Massive ones, structured ones, some with spiral hints, some already chemically mature. Stars burning with elements that require previous generations of stars to exist. That's the first crack. Because to get metals, carbon, oxygen, iron, you need stars to live and die. Supernovae, recycling, time, a lot of time. According to our timeline, the early universe simply didn't have enough of it. And yet, there they are. Not barely forming, already grown. We didn't just see galaxies too early. We saw too many of them. The early universe, according to models, should be sparse. Density fluctuations slowly amplifying under gravity, guided by dark matter scaffolding. Webb found something else. A crowd. A population density that implies structure formation running on fast forward, as if the universe skipped rehearsals and went straight to the performance. At first, we tried to soften it. Maybe the masses were overestimated. Maybe dust fooled us. Maybe the light was misleading. Then the data kept coming. We refined the measurements, we cross-checked with spectroscopy. Redshifts confirmed the distances. These objects were not imposters. They were exactly where they claimed to be. Shockingly early in cosmic history. This is where scale begins to wobble. Because the size of the universe is not just how far it extends in space, it's how much can happen within a given amount of time. A universe that produces massive galaxies quickly is not just efficient, it is roomy in ways our equations didn't budget for. Think of it like this. You walk into a city that was supposedly founded last year, and you find cathedrals, subways, layered neighborhoods, deep infrastructure. You don't just question the buildings, you question the calendar. That's what Webb did to cosmology. We've always told ourselves a clean story. The universe starts smooth, almost boring. Tiny ripples, gravity slowly pulling matter together, complexity emerging reluctantly, a long, patient climb from simplicity to structure. Webb looked back and saw complexity already waiting. Now bring yourself into this. You are standing on a planet orbiting a middle-aged star, in a galaxy that took billions of years to settle into its current form. Everything about our existence feels late, mature, after the fact. We're used to thinking of ourselves as arriving near the end of the story. Webb suggests the story may have been loud, crowded, and extravagant almost immediately. And that changes what early even means. If galaxies assembled faster, then distances calibrated using standard candles, like supernovae and Cepheid variables, start to drift. If expansion behaved differently in the past, then the inferred size of the observable universe may be off. Not by a little, by factors that matter. This is where the phrase true size begins to creep in. Not as a number, but as a tension. We measure the observable universe as about 93 billion light-years across. That's already a strange number, given the universe is only 13.8 billion years old. Expansion stretches space itself, allowing light to travel farther than time alone would permit. But those calculations assume a specific expansion history, a specific recipe, dark energy behaving consistently, gravity playing by known rules, early conditions unfolding predictably. Webb is not saying that recipe is wrong. It's suggesting it may be incomplete. Because if structure formed faster, then either gravity was stronger, matter behaved differently, or the initial conditions were not as smooth as we thought. Each option implies a universe that is not just larger, but richer, more aggressive in its use of space and time. And here's the quiet part that's easy to miss. When we revise the early universe, the revisions echo forward. Like pulling on one end of a spiderweb, distances shift, ages adjust, the inferred size of everything breathes outward. Not explodes, not collapses, expands subtly, unsettlingly. This is not the first time this has happened. Hubble did it, COBE did it, WMAP did it, Planck did it. Each new instrument tightened our view and forced us to admit the universe was slightly stranger than the last version allowed. James Webb is different because it's not tightening one parameter, it's stressing the entire narrative of emergence. We are used to thinking the universe grew up slowly. Webb is whispering that it may have been born already restless. And once you accept that possibility, you can't stop there, because size is not just about distance, it's about capacity, about how much reality can be packed into the first few 100 million years. And that question doesn't stay in the past. It rolls forward, toward us, toward the present, toward the edge of what we think we're standing inside. Because if the early universe was capable of more than we allowed, then the universe we inhabit may still be hiding scale we haven't accounted for yet. And Webb is still looking. Once that door opens, it doesn't close politely, it swings. Because the moment we accept that the early universe was already crowded, already organized, already productive, we are forced to revisit the most dangerous assumption we ever made about reality, that growth follows intuition. We like linear stories. Small becomes big, simple becomes complex, chaos settles into order. That's how cities grow. That's how children grow. That's how we imagine the cosmos growing, because it makes us feel oriented. But the universe has never promised orientation. What James Webb keeps brushing against is the possibility that the universe did not ease into existence. It arrived, loud, dense, over-prepared, as if the opening act skipped the tuning and went straight to volume. To feel why this matters, we have to shrink ourselves again. Not metaphorically, physically. Imagine compressing all of human history into a single calendar year. Agriculture appears in the final minutes of December 31st. Modern science flashes into existence in the last second. Everything we've ever done fits into a sliver so thin it barely counts as time. Now imagine the universe doing the opposite, packing complexity into its opening seconds. In standard cosmology, the first few 100 million years are supposed to be awkward. Hot gas, dark matter halos, slowly coaxing material inward. Stars flickering on, dying quickly, enriching space inch by inch. Galaxies should be tentative, fragile, rare. Webb doesn't see tentativeness. It sees confidence. Massive galaxies imply massive reservoirs of matter already assembled. That assembly requires gravitational wells deep enough to pull material together fast. And those wells don't come from nothing. They trace back to the very first fluctuations imprinted in space-time itself. This is where scale stops being abstract. Because those fluctuations, those tiny density differences in the early universe, set the entire stage. They determine how much matter clumps, how fast structures grow, how efficiently light turns into stars. We thought we had them measured, but Webb is hinting that those initial conditions may have been more intense, more uneven, more productive than our models allowed. Not wildly wrong, just wrong enough. And in cosmology, just wrong enough is everything. Because if early fluctuations were stronger, then gravity had more to work with. Structures could form faster. Galaxies could grow large before the universe was even 1 billion years old. But here's the escalation. Stronger early structure formation implies that the universe's effective size, its usable volume for making things, was functionally larger early on than we thought. Not bigger in meters, bigger in opportunity. This is the part that doesn't show up in headlines. The universe's true size is not just the edge we can see, it's the amount of cosmic real estate available for complexity to unfold. Webb suggests that real estate may have been abundant from the start, and that destabilizes the way we anchor everything else. Distances are inferred through brightness. Brightness depends on mass. Mass depends on formation history. Formation history depends on early conditions. Early conditions depend on inflation, the brief, violent expansion at the universe's birth that stretched quantum fluctuations into cosmic scaffolding. Inflation is already strange. Webb doesn't contradict it. It sharpens it. If inflation seeded stronger variations, then space may have expanded in a way that packed more structure into the same apparent volume. Two universes can be the same size, and yet one contains far more architecture. This is where intuition breaks. We imagine size as emptiness. Cosmology measures size as potential. Think of two warehouses. Same square footage. One is empty concrete. The other is stacked floor to ceiling with machinery, corridors, power lines, systems layered on systems. Which one feels bigger when you step inside? Webb is showing us a universe that feels like the second warehouse, far earlier than expected. And once you feel that, you start noticing secondary tremors. The Hubble Tension, our ongoing disagreement about how fast the universe is expanding today versus what the early universe predicts, stops looking like a bookkeeping error. It starts looking like a narrative mismatch. Two eras of the universe refusing to tell the same story. If early structure formed faster, then early expansion behavior may have been subtly different. Not radically, not enough to shatter relativity, just enough to skew distance ladders, tilt calibrations, stretch inferred scales. Suddenly, 93 billion light-years stops sounding final. It starts sounding provisional. We are not discovering that the universe is infinite. We are discovering that our confidence was finite. And here's where the human frame tightens. You are alive at a moment when the universe is already old. Stars have lived and died. Heavy elements exist. Planets form naturally. Life has chemistry to work with. We exist because the universe took its time. Or so we thought. But what if the universe was capable of building complexity almost immediately? What if the ingredients for planets, chemistry, maybe even habitability were seeded far earlier than we assumed? That doesn't mean life existed early. It means the runway was longer than we believed. A larger functional universe means more experiments, more chances, more cosmic throwaway attempts before anything like us ever showed up. We are not special because the universe waited for us. We are special because the universe didn't have to. That realization is uncomfortable. It shrinks ego, but it also expands belonging. We are not late to a quiet party. We are standing in the afterglow of a fireworks display that started before memory itself. James Webb doesn't say this directly. It doesn't need to. Its images do the talking. Ancient galaxies glowing calmly, unapologetically present where silence was expected. And the strangest part? They are not exotic in appearance. They look familiar. Disk-like shapes, central concentrations, hints of order that mirror what we see locally. The universe didn't invent structure slowly. It recognized it early. Which raises a final pressure point. If the universe could do this much so fast, then the boundaries we draw, observable edge, cosmic horizon, effective size, are more like curtains than walls. We see as far as light allows, but the universe may have been busy long before that light ever reached us. Not empty, not waiting, working. And that means the true scale of the universe is not just what we can map. It's what had time to happen before we ever arrived to look. Webb didn't make the universe bigger by adding distance. It made it bigger by revealing ambition. And once you notice that ambition, you can't unsee it, because it doesn't stop in the past. It echoes forward, toward the present, toward us, toward whatever scale the universe is still quietly preparing, behind the light we haven't seen yet. That's where the sensation shifts from surprise to vertigo. Because ambition doesn't belong to the past. Ambition implies trajectory. It implies momentum that didn't politely dissipate after the opening act. If the universe learned how to build fast, it didn't forget. It refined. And this is where true size stops being a historical question and starts pressing against the present. We tend to picture the universe like a photograph, a frozen frame with edges, distances, labels. But the universe is not a picture. It's a process. Size is not a static measurement. It's an evolving consequence of how space, matter, and energy interact over time. James Webb is catching the universe mid-sentence. To feel this, imagine standing in a cathedral while it's still being built. Scaffolding everywhere, stone dust in the air. You can't judge the final scale by what's finished. The ambition is encoded in what's already rising. Those early galaxies are scaffolding. They tell us something important. The universe was structurally fluent almost immediately. It knew how to make depth. It knew how to layer. It knew how to reuse material efficiently. That fluency means later eras, our era, are built on a foundation more capable than we assumed. This is where dark matter enters the story, quietly but decisively. Dark matter doesn't shine. It doesn't glow for Webb, but its gravity is the invisible hand shaping everything Webb sees. We model dark matter as slow, cold, patient, forming vast halos that shepherd gas into galaxies over time. But Webb's findings suggest those halos may have assembled earlier, faster, or more densely than expected. Not radically different particles, not magic, just behaviour that allows structure to lock in sooner. And when dark matter locks in early, it anchors space itself. It defines corridors. It creates gravitational basins where matter doesn't just drift, it falls. Falling is fast. That speed compounds. Early stars ignite. Early stars die. Metals spread. Cooling accelerates. More stars form. Feedback loops turn on. Galaxies mature. This is not a gentle universe. This is a universe that learned how to accelerate its own complexity. Now scale that up. Clusters of galaxies, collections of hundreds or thousands bound together, depend on long-term gravitational choreography. They shouldn't exist early. Webb isn't directly imaging clusters at the dawn yet, but the density of galaxies it sees implies the precursors were already forming, which means the cosmic web, the vast filamentary structure stretching across hundreds of millions of light years, may have snapped into shape earlier too. That web is the universe's skeleton. If the skeleton set early, then the body that grew around it had more room to flex. This is where our sense of containment starts to fail. We talk about the observable universe as if it's a box, a sphere centered on us, defined by the farthest light that's had time to reach Earth since the Big Bang. But the observable universe is not the universe. It's a bubble of visibility, a temporary window defined by speed limits and expansion history. Webb doesn't break that limit. It reminds us how misleading it is. Because when early structure is richer, the unseen regions beyond our horizon are not likely to be emptier. They are likely to be just as busy, maybe busier. The universe doesn't politely thin out where we stop looking. It continues. And that continuation matters because many of our models quietly assume uniformity, that on large scales the universe averages out, that extremes cancel, that nothing too wild is hiding just beyond view. Webb is challenging that comfort, not by showing chaos, but by showing order too early. Order early implies order elsewhere. This is where uncertainty becomes invitation instead of collapse. We don't say, we don't know. We say, the universe is still revealing how much it was capable of from the start. And that reframes size again. The true size of the universe is not just how far space extends, it's how many independent cosmic histories can unfold without ever intersecting ours. Each galaxy is a history. Each cluster is a civilization-scale archive of stars, deaths, rebirths. A larger, more efficient early universe implies more of these histories, more parallel tapes running without us ever hearing them. Humanity becomes a witness, not a center. But we're not excluded. We're implicated. Because the same physics that built those early galaxies built the Milky Way. The same rules that accelerated complexity there made planets possible here. You are made of atoms forged in stars that trace their ancestry back to those first fast-burning systems. The universe didn't wait to get good at making matter interesting. It practiced early. There's another subtle shift Webb introduces, and it's psychological as much as physical. We used to think of the early universe as fragile. Small changes mattered. Tiny perturbations could derail structure. Webb suggests robustness. A universe that can build galaxies quickly is a universe resilient to variation. It doesn't need fine-tuned patience. It tolerates messiness and still produces grandeur. That robustness implies scale in another dimension, durability. A durable universe can be larger because it doesn't require perfect conditions everywhere. It can afford waste, failed regions, silent expanses, and still generate spectacle. That's a universe that can be very big indeed. And now we arrive at a dangerous thought, not because it's speculative, but because it feels emotionally destabilizing. If the universe had more capacity early on, and if expansion is still accelerating today, then the future universe may be even more disproportionate than the past. Galaxies will drift beyond each other's horizons. Light will fail to cross expanding space. The observable universe of future observers will shrink, even as the total universe grows. We live at a moment of maximum access. We can still see the cosmic web. We can still detect ancient light. We can still reconstruct the opening chapters. Webb exists because this window exists. And Webb is telling us, the book is thicker than we thought. Not infinite, not mystical, just underappreciated. This is the emotional pivot. We are not small because the universe is large. We are small because the universe is generous. Generous with time, with structure, with opportunities for matter to try again and again until complexity sticks. James Webb didn't measure the universe's true size with a ruler. It measured it with surprise density, with the realization that wherever we thought nothing should be happening yet, something already was. And if that's true at the beginning, then the scale ahead of us, the parts of the universe still unfolding, still expanding, still arranging matter into forms we haven't named yet, may be even harder to emotionally contain. The universe didn't grow cautiously. It grew like it expected to be large. And expectations like that tend to fulfill themselves. Once you feel that expectation, it starts leaking into everything else we thought was settled. Because size is never alone. Size drags consequences behind it like gravity drags light. And the first consequence of a larger, more capable universe is this. Our models become memories, not maps. Models are stories we tell reality to keep it predictable. They're not lies. They're compressions. They shave off the wild edges so we can hold the whole thing in our hands without dropping it. James Webb didn't smash the models. It loosened their grip. And that matters, because cosmology is built on a delicate choreography of assumptions that quietly depend on each other. Change the tempo of early structure formation, and suddenly parameters that once fit together neatly begin to drift apart. Take dark energy, the quiet engine accelerating cosmic expansion. In our equations, it behaves politely, constant, smooth, a background hum that only becomes dominant late in the universe's life. But if the early universe assembled structure faster, then the handoff between matter-dominated expansion and dark energy-dominated expansion may not have been as clean as we imagined. The balance point shifts. Distances inferred from early light no longer align perfectly with distances inferred from later measurements. That's not a breakdown, that's a hint. It suggests the universe may have changed how it expands, not just how much. Now pause and feel that. Expansion is not space stretching like rubber. It's geometry evolving. It's the rules of distance subtly reweighting themselves over billions of years. A universe that reorganizes its geometry while building structure aggressively is not a passive arena. It's an active participant. This reframes the idea of breaking our models. Models don't fail because reality is chaotic. They fail because reality is ambitious. We designed our models to be cautious. The universe was not. And this is where the human frame sharpens again. You and I live inside a calm era. Stars form slowly. Galaxies drift lazily. On human timescales, nothing cosmic seems urgent. But the universe remembers speed. The early universe was not calm. It was decisive. It set patterns that still echo today. The distribution of galaxies, the temperature of the cosmic background, the abundance of elements. All of it traces back to choices made when the universe was young and unhesitating. James Webb is peaking at that decisive phase and realizing we underestimated its confidence. Which brings us to a quieter but more unsettling implication. If the universe was capable of doing more early, then it may also be capable of more elsewhere. Not everything needs to happen near us. Not everything needs to happen where we can see it. A larger functional universe implies that extremes, rare events, massive structures, unlikely configurations, are not just possible, they are statistically encouraged. In a small universe, rarity is meaningful. In a vast one, rarity is guaranteed. Somewhere beyond our horizon, there may be structures so large they warp local expansion. Regions where galaxies cluster in ways that make our cosmic neighborhood look sparse. Zones where star formation histories diverged wildly from ours because initial conditions leaned just a little harder in one direction. We don't need to see them to feel their implication, because the universe doesn't owe us representative sampling. Webb reminds us of that by revealing that even our own past was less average than we assumed. This changes the emotional texture of cosmology. We stop asking, is the universe strange? And start asking, how much strangeness fits? And the answer appears to be, a lot. But here's the stabilizing counterweight. For all this expansion of possibility, physics still holds. Gravity still curves spacetime. Light still has a speed limit. Atoms still obey quantum rules. Nothing supernatural is sneaking in. The universe isn't cheating. It's using its full allowance. Think of a game where the rules never change, but the player realizes, far too late, that the moveset is deeper than expected. Combos hidden inside combos. Pathways that were always legal, just overlooked. That's what Webb is exposing. And once exposed, we can't unknow it. The phrase true size stops meaning a boundary and starts meaning a budget. A budget of time, energy, and structure that the universe has been spending lavishly since the beginning. This brings us to one of the most human reactions to Webb's revelations. Discomfort masked as technical debate. Are mass estimates off? Is dust confusing infrared light? Are selection effects biasing our samples? These questions are valid, necessary. Scientists will refine, correct, argue, and recalibrate. But even after those corrections, the core sensation remains. Something formed earlier than it should have. And not just one thing. Enough things to demand attention. Enough things to suggest that the universe's early chapters were denser with activity than we planned for. We are not watching a glitch. We are watching a pattern emerge. And patterns, once recognized, don't politely vanish. This is where uncertainty becomes propulsion. Not, we don't know, but we may have underestimated how quickly reality finds its footing. A universe that finds its footing fast can run far. Now stretch that forward. If the universe learned early how to organize matter efficiently, then its future may be just as decisive in a different direction. Expansion accelerates, horizons shrink, isolation increases. In the far future, Galaxies outside our local group will fade beyond detectability. Observers then will see a smaller universe, not because it is smaller, but because access has diminished. We live before that narrowing. Webb exists because we exist, before the lights dim. And what it's telling us is not just about size, it's about timing. We are standing at a moment when the universe's full ambition is still partially visible. Early structures still speak through ancient light. Late-time expansion hasn't yet erased their voices. That combination is rare. It won't last forever. Which makes this revelation feel less like academic revision and more like a fleeting alignment. A moment when the universe allows itself to be seen as it really is. Larger in capacity, richer in history, more assertive in its evolution than our calm equations suggested. We are not lost inside it. We are briefly aligned with it. James Webb didn't make the universe bigger by stretching space. It made it bigger by reminding us that the universe has always been playing a longer game than we assumed. And once you accept that, the question stops being, how big is the universe? It becomes, how much of it did we ever expect to handle? At that point, size stops feeling like a measurement and starts feeling like a pressure, something pushing gently but constantly against the edges of what we thought we could contain. Because a universe that plays a longer game doesn't just outlast us, it outthinks our expectations. We assumed beginnings are fragile. Webb is suggesting beginnings can be assertive. And assertive beginnings don't just fade into quiet middles, they set trajectories. To understand how deep this goes, we have to revisit a moment so early it barely qualifies as time at all. Inflation. A burst of expansion so fast it makes every other speed in the universe look irrelevant. Space itself ballooning, smoothing, stretching quantum irregularities into cosmic blueprints. For decades, inflation has been our solution to multiple problems at once. Why the universe looks uniform. Why distant regions share the same temperature. Why structure exists at all. It worked, elegantly, but it also lulled us into thinking inflation left behind a neat, almost minimalist universe. Clean initial conditions, gentle ripples, a calm stage. James Webb is whispering that the stage may have been more crowded when the curtain rose. Not chaotic, not broken, just fuller. If inflation amplified fluctuations slightly more in some modes than we modelled, then the early universe wouldn't just be smooth with wrinkles, it would be smooth with intentional texture, the kind that gravity can immediately exploit. This doesn't overthrow inflation, it sharpens it, suggests it may have produced a universe preloaded with structure-ready patterns. And once patterns are in place, growth accelerates. This is why the phrase breaks our models is emotionally accurate even if technically overstated. The equations still work, the constants haven't betrayed us, but the story we wrapped around them, the pacing, the tone, the assumed restraint, that's what's cracking. We expected the universe to hesitate. It didn't. Now here's the escalation most people miss. If the universe's early expansion and structure formation were more productive, then the total amount of stuff, matter, energy configurations, gravitational wells, within the observable universe could be higher than inferred. Not because new matter appeared, but because our inferences depend on brightness to mass relationships, calibrated on a slower story. Change the story, and the accounting shifts. That means when we say, this galaxy weighs this much, or this cluster spans this scale, those numbers are only as solid as the assumptions beneath them. Webb isn't erasing those assumptions, it's asking us to renegotiate them. And renegotiation is where scale quietly grows. Because when uncertainties expand symmetrically, the safest move is to allow more room, not less. This is how cosmology evolves, not by tearing down walls, but by realizing the room was always larger than the furniture arrangement implied. We are now in that phase, and the human reaction to this is telling. Awe mixed with anxiety, excitement laced with defensiveness, a sudden need to protect the familiar story. That's not scientific weakness, that's human instinct. We like a universe we can narrate cleanly, beginning, middle, end. a slow rise to complexity that mirrors our own sense of development. But the universe does not mirror us. We mirror it. And Webb is reminding us that the universe's rhythm is not ours. This realization spills into another domain that's been hovering quietly nearby: time. A universe that forms galaxies quickly compresses its meaningful history. More happens per unit time. That doesn't make the universe younger or older, it makes it denser in events. Think about two movies with the same runtime. One is slow, atmospheric. The other is relentless, scene after scene, revelation after revelation. Same length, completely different experience. Webb is telling us the universe's opening act may have been the second kind of film, and that changes how we emotionally interpret cosmic age. 13.8 billion years no longer feels leisurely. It feels efficient. Enough time for not just stars and galaxies, but multiple waves of structure, feedback, refinement, and stabilization to unfold before our galaxy ever finished assembling. We are not late, we are downstream of an early torrent of creation. This reframes humanity's place again, not as a fragile fluke emerging just in time, but as a late beneficiary of a universe that solved complexity early and kept iterating. And iteration implies scale. Iteration implies retries. Iteration implies that the universe can afford inefficiency because it has room to spare. A small universe must conserve. A large one can experiment. James Webb is revealing a universe that experiments freely, which brings us to the most emotionally charged implication of all, one we rarely say out loud because it feels destabilizing. If the universe had more capacity early on, then nothing about our existence is pushing against the limits. We are not crowding the universe. We are barely registering. That doesn't make us meaningless. It makes us unthreatening. And that's oddly comforting, because it suggests the universe is not finely balanced on our presence. It doesn't need us to justify its scale. It doesn't bend to accommodate us. We get to exist without burdening the whole. We are not holding the universe together. We are being carried by it. That perspective only becomes possible when scale grows beyond our emotional grasp. And Webb is pushing us there gently but firmly. Every ancient galaxy it reveals is not just a data point. It's a reminder that the universe was already busy before any story that includes us could even begin. Yet here we are, able to see it, able to reconstruct those early chapters, able to notice when the universe exceeds our expectations. That ability is not guaranteed in every era. It won't exist forever, which is why this moment feels charged. We are alive at a time when the universe is large enough to surprise us, but still visible enough to confront. James Webb didn't break our models in the way explosions break structures. It broke them the way growth breaks clothing. The universe didn't change. We did. We realized that the true size of the universe isn't something we measure once and move on from. It's something that keeps reasserting itself whenever we build a better way to look. And Webb is not done looking, which means the pressure hasn't peaked yet. It's still building. That building pressure has a strange effect. It doesn't feel like panic. It feels like anticipation. Like standing near a door you didn't know existed, feeling air move through the cracks, realizing there's a much larger room on the other side. Because once we accept that the universe's early capacity was underestimated, we are forced to confront a quieter implication. Our cosmic neighborhood may not be representative at all. We like to believe the Milky Way is typical, an average spiral galaxy in an average region of space. Not too dense, not too empty. Comfortable. That belief is doing emotional work for us. James Webb is making it harder to maintain. If the early universe produced galaxies rapidly and in abundance, then cosmic environments may vary far more dramatically than we assumed. Some regions may have burned through star formation early, becoming quiet faster. Others may have stayed active, churning out stars for billions of years more aggressively than we ever experienced locally. Our galaxy could be a late bloomer in a universe full of early overachievers. And that matters because size is also about variance. A truly large system doesn't just have more of the same thing, it has more ways for things to differ. Think of an ocean. Size isn't just how far it stretches, it's how many currents, temperatures, ecosystems it can support simultaneously. A pond can be measured, an ocean must be explored. Webb is telling us the universe is oceanic. This is where our language begins to strain. We talk about cosmic averages because they make the universe feel manageable. But averages erase extremes, and extremes are where scale announces itself. Early massive galaxies are extremes. They tell us that cosmic history is not smooth, it's lumpy, uneven, opportunistic. Some regions hit the jackpot early, others lagged. And in a universe with enough room, that unevenness doesn't need to resolve. It can persist. Which means there may be regions of the universe where galaxy formation ran so efficiently that they exhausted their gas quickly, collapsing into dense collections of ancient stars. Other regions where gas remained diffuse longer, delaying complexity. Entire cosmic neighborhoods living on different schedules. We exist in one of them. Not the fastest, not the slowest, just one. That realization has a subtle psychological effect. It loosens the idea that our vantage point is privileged. We are not at the center of the story. We are at one coordinate in a story with more branches than we can trace. But here's the anchor. We can still trace some of them. James Webb is not just showing us early galaxies. It's giving us a statistical glimpse of how many stories were already unfolding when the universe was young. And the count is higher than expected. More stories mean more volume, not necessarily more distance, but more narrative capacity. This is where the phrase true size becomes almost metaphorical, but not inaccurately so. A universe that can host many independent histories without interference is effectively larger than one that funnels everything through a narrow channel. Our models tended to funnel. Webb is revealing sprawl. Now bring yourself back into the frame. You are a human on Earth, living less than a century, thinking about events that unfolded over billions of years and across distances light struggles to cross. And yet, you can follow this. You can feel the implication. You can sense that the universe is not just big, but overqualified. That feeling of being dwarfed but not erased is important, because it's the emotional state that lets curiosity survive scale. If the universe were merely larger, we could shrug. But a universe that is larger and more capable than expected demands attention. It asks us to stay. This is why Webb's images went viral. Not because people understand redshift or infrared spectroscopy, but because they felt something was off in a compelling way. Galaxies that looked too grown up for their age. A past that refused to look primitive. We recognize that feeling instinctively. It's the feeling of realizing a system has been running longer or harder than advertised. And once you recognize it, you start looking for it elsewhere. In cosmology, that leads to questions about what we haven't seen yet. If Webb can already detect massive galaxies at the edge of visibility, then just beyond that edge, beyond the cosmic horizon, there may be regions where structure formation was even more extreme. We cannot observe them directly. But we don't need to invent them. In a universe that early ambition seems to be a feature, not a bug, extremes are not optional. They're inevitable. This is not speculation layered on speculation. It's extrapolation grounded in revealed behavior. The universe has shown us it doesn't wait. So we stop assuming restraint where none has been demonstrated. And that's the moment our models shift from conservative to permissive. Not careless, not wild, just honest. Honest about the fact that our universe may be far more generous with outcomes than our tidy equations suggested. And here's where the story bends back toward meaning. A universe that allows many histories also allows many futures. Not all futures converge. Not all regions end the same way. Some may fade early. Others may remain active long after our local group goes dark. Scale gives options. We live in a universe with options. That doesn't make our moment insignificant. It makes it contextual. We are part of a distribution, not an exception. And distributions only make sense in large systems. This is why Webb's quiet revolution doesn't feel like despair. It feels like recalibration, like realizing the map you were using was drawn for a smaller landscape. You don't throw the map away. You redraw it. But redrawing takes time and humility and willingness to accept that the edges may keep moving. James Webb is not the last instrument that will do this. It's the first of a new generation, one that looks at the universe not as a solved puzzle, but as a system that keeps revealing how much it can do. And that means the pressure we feel now, the sense that our old boundaries are too tight, is not a problem. It's a signal. A signal that we are finally measuring the universe in the units it prefers. Not just distance and age, but capacity. Capacity for structure. Capacity for history. Capacity for surprise. The universe didn't get bigger when Webb launched. We just stopped underestimating how much it was already holding. And once that underestimation dissolves, there's no comfortable place to stop. Because every improvement in vision now comes with a quiet expectation. Whatever we see next will probably be doing more than we allowed for. And that expectation, once internalized, changes how we watch the universe forever. Not with caution, with readiness. Readiness changes the way we interpret silence. Because when you stop assuming restraint, absence stops meaning emptiness. It starts meaning distance, or timing, or perspective. And that shift is subtle, but irreversible. For most of our history, the universe felt quiet because we were deaf to it. Then telescopes gave it a voice. Hubble gave it memory. James Webb is giving it tempo. And the tempo is faster than we expected. Once you feel that, a new question rises. Not about the past, but about limits. If the universe can assemble galaxies early, distribute complexity unevenly, and still accelerate its expansion, then what exactly is constraining it? The answer is uncomfortable in its simplicity. Very little. The fundamental laws don't forbid scale, they permit it. They regulate interactions, not ambition. Gravity doesn't care how large a structure becomes, as long as space-time can curve around it. Expansion doesn't care how much history is left behind, as long as energy density allows acceleration. There is no cosmic referee calling timeouts, which means the only reason we ever thought the universe might be modest is because we are. Our intuition evolved in small environments. Our narratives favour containment. We mistake familiarity for universality. James Webb is systematically undoing that mistake. Let's anchor again in something human. Picture a city you've lived in your entire life. You know its streets, its neighbourhoods. You think you understand its scale. Then one day you climb a hill you've never bothered with and realise the city extends far beyond what you've ever traversed. Entire districts you've never named. Lives unfolding without intersecting yours. The city didn't grow overnight. You just changed vantage points. Webb is that hill. And from that vantage, the early universe doesn't look tentative or sparse. It looks like a metropolis already humming before the official founding date. Now zoom further out, because this isn't just about galaxies, it's about statistics. Our cosmological models are probabilistic. They predict how often structures of a given size should appear at a given time. Webb is not finding impossibilities, it's finding too many improbabilities. And probability is where scale hides. In a small universe, rare events are meaningful outliers. In a large universe, they are expected. Guaranteed even. If you roll enough dice, sixes stop being surprising. Webb is telling us the universe may have been rolling a lot of dice very early. That realization drains shock from extremes and replaces it with inevitability. Of course, massive galaxies formed early, somewhere. Of course, structure matured quickly, in some regions. Of course, complexity appeared before our narrative said it should, given enough volume. This doesn't diminish the wonder, it deepens it, because it reframes the universe as a system that doesn't wait for permission. It explores its own parameter space aggressively, and we are seeing the fossil record of that exploration. This leads to another quiet shift. Our obsession with fine-tuning begins to soften. We've long worried that the universe seems delicately balanced for complexity, as if a small change would ruin everything. Webb hints at the opposite. The universe may be robust, not fragile, not knife-edged, capable of producing structure across a wider range of conditions than we assumed. Early overperformance suggests tolerance, margin, slack. A system with slack can scale, and slack is the enemy of smallness. If the universe tolerates variation, then it doesn't need to be narrowly optimized. It can sprawl. It can allow wasted regions, failed structures, quiet expanses, and still produce abundance elsewhere. This is the kind of universe that can be very large without collapsing into uniformity. And once you accept that, the idea of a true size becomes almost misleading, because size stops being a boundary and becomes a distribution. How far does the universe go? Far enough that our region doesn't define it. How much happens? Enough that our history doesn't dominate it. How many outcomes exist? More than one narrative can track. That's not infinity. That's excess. Excess is emotionally harder to process than infinity. Infinity is abstract. Excess is tangible. It means more than you planned for. James Webb is a machine for revealing excess. And excess forces humility, not the performative kind, but the practical kind. The kind that changes how you build theories, how you interpret anomalies, how willing you are to let go of elegant simplicity. We like elegant universes, clean beginnings, predictable growth, symmetry everywhere. The real universe appears to like productivity, which brings us to a final turn in this movement of thought, one that loops back to us in a way that's quietly grounding. A universe with excess is not indifferent, it is generous. Generous with chances, generous with pathways, generous with outcomes that don't need to converge on us to justify themselves. That generosity is what allowed stars to form early, galaxies to mature quickly, elements to spread widely. It's also what allowed, much later, a small planet around an unremarkable star to develop chemistry that could ask these questions at all. We are not central. But we are not accidental either. We are downstream beneficiaries of a universe that doesn't hoard potential. James Webb is not telling us that the universe is too big to matter. It's telling us the universe is big enough to include us without contortion. And that's a different emotional posture entirely. It means our presence doesn't strain reality. It fits. We are not squeezing into a universe tuned precisely for us. We are emerging naturally within a universe that had room to spare. That realization doesn't shrink us, it stabilizes us. Because it removes the burden of cosmic justification. We don't need to be special to be meaningful. We don't need to be rare to be real. The universe didn't have to bend to make us. It simply kept building. And somewhere in that building, amid early galaxies that formed too fast, structures that matured too early, expansion that refuses to slow, we arose as observers. Not at the beginning, not at the end. At a moment when the universe is large, expressive, and still legible. That legibility is fading. In the far future, much of this structure will slip beyond view. Observers then will infer a smaller universe, not because it is smaller, but because access has narrowed. We live before that narrowing. We live when excess is still visible. James Webb exists because we live at that moment, and it is using that moment to say something simple, unsettling, and oddly comforting all at once. The universe did not grow cautiously. It grew like it expected to have witnesses. And we are here, briefly, improbably, deliberately enough, to notice. That doesn't make us the point. It makes us part of the proof. That sense of proof lingers because it carries weight. Not the weight of obligation, but the weight of placement. We are not here by cosmic accident or by cosmic design. We are here because the universe is the kind of system where being here happens. And once you internalize that, you start noticing something else James Webb is quietly forcing us to confront. Our sense of cosmic normal is wildly undertrained. We assumed the universe's default state was emptiness, punctuated by rare islands of matter. Webb is showing us that density, of activity, of structure, of history, may be the rule rather than the exception. Even in the early universe, matter didn't wait patiently in the dark. It rushed. It collapsed. It ignited. That means emptiness may not be the universe's natural condition. It may be a late-time artifact. Think about that. The vast voids we see today, the cold, dark expanses between galaxy filaments, may be the result of overachievement, not scarcity. Matter moved fast, clustered early, leaving behind regions drained of fuel. Void is not absence. Void is aftermath. This flips a deep intuition. We tend to imagine the universe starting empty and filling slowly. Webb suggests it may have started full and spent the rest of its life redistributing. Redistribution is a hallmark of large systems. Small systems conserve locally, large systems rearrange globally, and the universe is the largest system we know. So when we ask about its true size, we are really asking, how much rearrangement can it support before we lose track of it? James Webb doesn't give us a number. It gives us a behaviour pattern. That sculpting began earlier than expected, which implies the chisel was sharp from the start. Now zoom your attention inward, toward what that means for everything that came later. For galaxies like ours, for stars like our Sun, for planets like Earth. Our galaxy did not form in isolation. It assembled within a web whose strands were already in place. That web's geometry, its thickness, its tension, its reach, was set long before the Milky Way ever existed. If that web formed earlier and more robustly than we thought, then our galaxy's path through cosmic history was less precarious than assumed. It wasn't threading a needle, it was moving through a corridor. That corridor gave us stability, repeated star formation, heavy elements, time. This is the quiet, emotional payoff of scale. A larger universe is a safer one. Not safe in the human sense. Cosmic radiation, stellar explosions, extinction events still happen, but safe in the sense that it can absorb loss without unravelling. Entire galaxies can fade. Entire regions can go dark. The universe doesn't notice. And yet it continues building elsewhere. That resilience is scale, expressed as character. James Webb is not just expanding our measurements, it's revealing the temperament of the universe. And the temperament is confident. Confident enough to let complexity bloom early. Confident enough to waste entire regions. Confident enough to expand relentlessly without worrying about what gets left behind. That kind of confidence requires room. Which brings us to a realization that's easy to miss because it feels philosophical, but it's grounded in observation. The universe behaves like it expects to be large. Not infinite, not boundless in a hand-wavy sense, but large enough that nothing needs to be tightly scheduled. That expectation is visible in how quickly it forms structure, how unevenly it distributes matter, how casually it accelerates expansion. These are not the behaviours of a constrained system. They are the behaviours of one with slack. Now feel how different that is from how we usually talk about cosmology. We talk about balances, coincidences, fine-tuning, knife-edge parameters that, if altered slightly, would ruin everything. Webb is hinting that the universe may be less brittle than we feared. Not because the laws are different, but because the outcomes are buffered by size. In a buffered system, small deviations don't cascade into collapse. They get absorbed, redirected, averaged out over vast volumes. That means the universe can afford to surprise us repeatedly without destabilizing itself. And it has. Every generation of telescopes has found something too early, too large, too organized. Webb is just the first to find so many of these things at once that we can't dismiss them as quirks. The pattern is now undeniable. The universe consistently does more sooner than we expect. And that pattern implies something about the parts we can't see yet. Beyond the observable horizon, beyond the reach of any telescope we can build, space continues. Not as blank extension, but as continuation of behaviour. We don't know the details. We don't need to. We know the character. A universe that builds eagerly in one region is unlikely to be lethargic just beyond view. So the true size of the universe stops being a question of kilometres or light years and becomes a question of how much behaviour extends beyond our access. And the answer appears to be most of it. That doesn't diminish the value of what we see, it elevates it, because we are sampling from a much larger distribution. What we observe is not the universe, it's a slice. And Webb is showing us that even this slice is richer than expected. Which brings us back to the human presence again, not as a punchline, but as a stabilizer. You are a finite being. You experience life sequentially. You make sense of the world through stories with beginnings and ends. The universe does not operate that way. But it produced you anyway. Not by tailoring itself, but by being large enough that localized narratives like yours can arise without threatening the whole. That's not indifference. That's capacity. And capacity is what we've been circling this entire time. James Webb did not announce that the universe is infinite, or unknowable, or broken. It quietly revealed that the universe has more room for events than we budgeted for. More room for galaxies to form Earth. More room for structure to mature quickly. More room for histories to unfold without intersecting ours. More room for futures that don't converge on our expectations. And more room, ultimately, for observers like us to exist briefly, look outward, and realize the room is bigger than we thought. That realization doesn't end the story. It shifts its scale. Because once you accept that the universe has been under no pressure to conserve space, time, or outcome, once you accept that it has always been operating with margin, you stop asking when it will run out. You start asking what it will do next. And James Webb, still staring into ancient light, still collecting photons that began their journey before Earth had oceans, is not answering that question. It's inviting it. Inviting us to watch carefully. Because in a universe that grew like it expected witnesses, the next surprise is not an anomaly. It's tradition. Tradition changes how we interpret repetition. Once something happens often enough, it stops being an exception and starts being a signal. And Webb has given us enough signals now that ignoring them would require more explanation than accepting them. The universe keeps outperforming our expectations. That's the pattern. And patterns demand escalation. So now we turn to a thought that used to feel speculative, even indulgent, but is beginning to feel structurally unavoidable. The observable universe may be a particularly modest slice of a far more extreme whole. Not because it's small, because it's filtered. Everything we see is constrained by light travel time, cosmic expansion, and the gradual loss of information as space stretches. That means the universe we can access is not just limited in distance, it's limited in character. We see what hasn't yet slipped away. Webb is peering right up against that boundary and finding maturity where youth was expected. That suggests something important about the regions just beyond reach. If structure can mature quickly, then by the time light from more distant regions would have reached us, those regions may already have moved on, collapsed further, clustered more tightly, or drifted out of causal contact entirely. We are not seeing the universe at its most extreme. We are seeing what remains visible. That's a crucial shift. Because it means the universe's true scale is not simply what exists, but what remains accessible. And accessibility is shrinking over time. We are early enough to see deep into the past, but late enough that much has already been hidden. That combination is rare. It gives this moment a strange emotional texture, urgency without panic, awe without despair. We are not racing against the end of the universe. We are racing against forgetting. James Webb is a memory recovery device. It is pulling back light that would otherwise fade into irrelevance as expansion stretches wavelengths beyond detectability. It's preserving evidence that the universe was already busy long before our local story began. And in doing so, it's revealing something deeply counterintuitive. The universe may have reached peak complexity locally very early. Not everywhere, not all at once, but enough to suggest that what we consider late-time structure may actually be the afterglow of an early surge. This reframes the cosmic timeline. Instead of a slow ramp from simplicity to complexity, we may be looking at a burst of creativity, followed by long redistribution. Early galaxies ignite fast, grow large, then gradually settle, merge, fade. Later epochs don't invent complexity from scratch, they remix it. That makes the early universe the most consequential era by far, and Webb is our first instrument capable of resolving that era in detail. Now bring your attention back to scale, not spatial scale, but narrative scale. How many cosmic stories began before ours had the raw materials to exist? How many galaxies formed, evolved, and stabilized before the Milky Way finished assembling? How many stellar civilizations, if such things ever arise elsewhere, could have risen and fallen without leaving a trace detectable to us? A universe that formed structure early has a long tail of unseen histories. That's not speculation layered on science, it's implication layered on observation. Early structure implies early opportunity, and opportunity implies outcomes. Not necessarily life, not necessarily intelligence, but history. And history is scale expressed over time. This is where the idea of the universe's true size becomes almost unsettling, not because it's infinite, but because it may be overpopulated with pasts. We live among the survivors. The galaxies we see today are not the first. They are the ones that lasted. Webb is showing us glimpses of their ancestors, some of which may no longer exist in recognizable form. Merged, cannibalized, faded into diffuse halos of stars. The universe is not just big, it is layered. Layered with outcomes that don't persist. And a layered universe doesn't feel empty, even when it looks dark. Darkness becomes archival. When we stare into deep space, we are not looking into nothingness. We are looking into regions where activity has either already concluded or slipped beyond our access. This transforms how we emotionally process cosmic emptiness. The voids between galaxy filaments are not blank pages. They are margins. Margins filled with erased draft. James Webb is teaching us to read those margins differently, not by filling them in with fantasy, but by recognizing what kind of system produces margins in the first place. Only a large, productive system leaves behind large, quiet regions. Small systems don't have leftovers. And now we confront another implication, one that loops back to physics in a way that feels grounded rather than abstract. If the universe assembled structure early and efficiently, then the constraints on cosmological parameters may be looser than we assumed. Dark matter properties, initial fluctuation amplitudes, baryon to photon ratios. These quantities may not need to be finely tuned to produce a universe like ours. There may be a wider, viable range. That widens the phase space of possible universes. And a wider phase space is a hallmark of scale. It means the universe can be large not just spatially, but optionally, capable of existing in many configurations that still produce richness. This undermines the intuition that we live in a knife-edge cosmos. Instead, we may live in a forgiving one. Forgiveness at cosmic scale is not softness, it's robustness. And robust systems scale naturally. James Webb didn't set out to reveal robustness. It just kept finding structure where fragility was expected. That's enough. Now pause and feel the human response to this, not intellectually, but emotionally. It's not fear. It's not insignificance. It's a recalibration of relevant. We are relevant not because the universe needed us, but because we are capable of noticing when the universe exceeds its own advertised limits. That noticing is not trivial. Most matter never notices anything. Most galaxies will never know how they formed. We do. And that awareness exists only briefly, in a narrow window of cosmic time, on a small planet, around a modest star, in a galaxy that was not among the earliest or the largest. That combination is unlikely, but not miraculous in a universe with enough room. And that's the point. Improbability stops feeling mystical when scale is large enough. James Webb is making improbability feel ordinary, which is perhaps the most destabilizing and calming thing it has done at the same time. We are not anomalies. We are samples. And samples imply a large population. That population is the universe itself, unseen in full, but increasingly difficult to underestimate. As Webb continues to collect data, refine redshifts, map early galaxies in greater numbers and detail, one thing is becoming clear. Whatever the universe's true size is, it is not going to be smaller than we thought. Every correction points outward. Every surprise adds capacity. Every early galaxy pushes the effective boundary of what the universe was capable of at birth. And birth matters, because systems that begin big rarely end small. They fragment, they redistribute, they thin out locally, but globally, they retain their scope. The universe may grow quieter over time, darker, more isolated, but that quiet is not the absence of scale, it's the echo of it. James Webb is letting us hear that echo while it's still audible. And once you've heard it, once you've felt how much activity preceded you, how much structure matured before your story could even begin, you stop asking whether the universe is too big to matter. You start asking a better question. How did we ever convince ourselves it was going to be manageable? That question hangs because it doesn't accuse the universe. It accuses our expectations. And expectations, once exposed, don't collapse. They recalibrate. We convinced ourselves the universe would be manageable because we learned it in layers. Each generation inherited a slightly larger picture than the last. Each expansion felt incremental, comfortable. James Webb skipped the increment. It leapt. And leaps are disorienting because they don't give intuition time to adapt. What Webb did was not to show us something entirely new, but to show us too much of the old, too early. Too many galaxies, too much structure, too much order packed into a time frame we had labelled primitive. Primitive is a human word. The universe never agreed to it. Now, feel the tension this creates in how we think about cosmic beginnings. We imagine beginnings as chaotic, unstable, uncertain. But Webb's universe doesn't look uncertain. It looks decisive. Decisive beginnings imply decisive constraints, or the absence of them. This is where the story brushes against one of the most uncomfortable realizations in cosmology. The early universe may not have been delicately balanced on a knife edge. It may have had room to move, room to form galaxies early, room to tolerate density variations, room to create massive structures without destabilizing itself. That room is scale expressed as freedom, and freedom is dangerous to tidy theories. Because tidy theories prefer uniqueness. They like singular solutions. They like universes that work only if everything lines up just right. Webb is nudging us toward a messier truth. The universe may work across a broader range of initial conditions than we allowed. Not infinite, not arbitrary, but generous. And generosity, at cosmic scale, changes everything. It means the universe didn't need to try hard to make structure. It didn't need fine-tuned patience. It had enough volume and time density that complexity could arise quickly and redundantly. Redundancy is the signature of large systems. Small systems optimize, large systems replicate. Webb is revealing replication. Multiple massive galaxies forming early. Multiple paths to maturity. Multiple histories running in parallel. That's not a universe scraping by. That's a universe operating with surplus. Now turn that surplus forward in time. A universe that forms structure quickly also exhausts some of its opportunities early. Gas gets locked into stars, star formation peaks, feedback heats surrounding regions, activity shifts. The long, quiet Middle Ages of the universe, the era we live in, are not the build-up. They are the aftermath. That's a subtle but profound inversion. We are not living during the universe's rise. We are living during its settling. The fireworks already went off. James Webb is showing us the smoke trail. And smoke trails tell you how violent the explosion was. This reframes cosmic melancholy. We often speak of a future where galaxies fade, stars burn out, expansion isolates everything, a slow heat death. But if the universe's most intense creative phase happened early, then decline is not failure, it's completion. Completion doesn't erase scale, it preserves it. Think of a city after a festival. Streets quiet, lights dimmed, but the infrastructure remains. The scale doesn't vanish because activity slows. The universe may be heading toward quiet, but it is a quiet built on enormous groundwork. And that groundwork is what Webb is uncovering. This brings us to a human-scale mirror that feels uncomfortable but clarifying. We often measure our own lives by growth: childhood, learning, building, expanding. Slowing feels like loss. The universe doesn't share that psychology. It front-loaded its creativity, and that means that what we interpret as vast emptiness may be the universe in a post-creative state, not an unfulfilled one. Void is not waiting. Void is resting. That idea only works if the universe had enough room to finish much of its work early. James Webb is making that plausible. Now tighten the lens again on the phrase true size, because by now it should feel slippery, not evasive, but layered. The true size of the universe is not a distance. It's a capacity curve. How much structure can form per unit time? How much variation can exist simultaneously? How many histories can run without interacting? How much loss can be absorbed without collapse? Those are the questions Webb is forcing us to ask. And every answer points the same direction. Upward. More capacity. More tolerance. More room. Not infinite, but far beyond minimal. Which means the universe we inhabit is not finely tuned for existence. It is generously permissive of it. That generosity explains something that used to bother us. Why does the universe seem indifferent to us? Because indifference is not hostility. It's scale. Large systems don't react to small perturbations, they absorb them. The universe doesn't notice our presence because it doesn't need to adjust for it. And that's okay. In fact, it's liberating, because it means our significance doesn't come from cosmic dependence, it comes from cosmic awareness. We matter because we can detect when the universe outgrows our models. James Webb is an extension of that awareness, a tool built by a small species to interrogate a system that does not care, but still reveals itself when asked properly. And it reveals itself not as minimal, not as fragile, not as barely holding together, but as comfortable with scale. This is why the emotional tone of Webb's discoveries is not dread, it's steady awe. Awe that doesn't spike and crash, awe that accumulates. Every early galaxy adds weight, every overgrown structure adds pressure, every mismatch between expectation and observation nudges our sense of reality outward. And that outward movement has not stalled. Webb is still gathering data, still refining mass estimates, still mapping the early universe in increasing detail. And each refinement is not shrinking the picture, it's sharpening the excess. This is not a revolution in the sense of overturning laws, it's a revolution in confidence. The universe appears confident in its own scale, and that confidence invites us to relax ours. We don't need to protect smallness, we don't need to insist on restraint, we don't need to force the universe into a story that makes us comfortable. We can let it be large, because letting it be large doesn't erase us. It places us accurately. We are observers in a system that does not revolve around us, but that allowed us to emerge, briefly, during a window when its past is still visible and its future is still open. That window is narrow. James Webb is using it, and it is telling us something we should have suspected all along. The universe was never trying to be just big enough. It was always comfortable being more. That comfort changes how we interpret boundaries, because once you stop thinking the universe is operating near a limit, every apparent edge starts to feel provisional, less like a war, more like a horizon that happens to be passing through us. And horizons are not endings. They're artifacts of position. This is where James Webb's quiet disturbance becomes almost philosophical without ever leaving physics. Because the telescope isn't telling us the universe is unknowable. It's telling us that what we can know is conditional, on timing, on vantage, on how quickly reality moves compared to our ability to observe it. We are not late to the universe. We are late to some of its consequences. The early universe moved fast. It laid down structure quickly. It decided where matter would flow and where it would thin out. By the time our galaxy began forming in earnest, the large-scale geometry of everything was already fixed. That geometry is still carrying us. And this is where true size gains a new dimension. Not just how far the universe extends, but how much inertia it carries from its beginnings. Inertia is memory. The universe remembers how it started, not consciously, but mechanically. Early density patterns still guide galaxy motions today. Ancient fluctuations still dictate where matter congregates. The past is not gone, it's embedded. James Webb is letting us see how much memory was encoded early, more than we expected, which means the universe's present scale is not just about expansion. It's about legacy. A system that imprints so much structure early does not need to constantly reinvent itself. It coasts. It evolves within channels already carved. That carving happened faster and deeper than we assumed. Now pause and consider the emotional difference between a universe that slowly sculpts itself and one that rapidly engraves its foundations. The first feels tentative, the second feels assured. Webb's universe feels assured, and assurance at that scale is unsettling only if you expect fragility. If you let go of that expectation, assurance becomes grounding, because it tells us that the universe is not at risk of unraveling if our models wobble. It is not threatened by our confusion. It is not waiting for us to understand it properly before continuing. It has, which frees us from a subtle anxiety we rarely name. The fear that if we don't get cosmology exactly right, reality will somehow fall apart. It won't. Reality is not depending on our comprehension. James Webb makes that clear by showing us that the universe has already exceeded multiple generations of our best guesses and kept going. Now, there is a temptation here to lean into cosmic nihilism, to say, if the universe is so large, so confident, so indifferent, then nothing matters. But that temptation confuses scale with meaning. Scale doesn't erase meaning. It redistributes it. In a small universe, meaning must be centralized. Everything must point inward. In a large universe, meaning can be local. Local meaning is not weaker, it's freer. You don't need to matter to everything, to matter fully to something. The universe's scale gives us permission to be specific. James Webb is not diminishing human relevance. It's removing a burden we never needed to carry, the burden of cosmic centrality. We don't need the universe to be small enough to wrap around us. We need it to be stable enough to host us. And Webb is showing us that stability came early and has persisted. Which brings us to another subtle but powerful implication. Predictability may be more limited than stability. The universe can be stable without being predictable in detail. Large systems often are. Weather is stable, climate is stable. Specific storms are not predictable far in advance. Cosmology may be similar. We can trust that gravity behaves, that expansion continues, that structure persists, but the specific pathways, the exact pacing, the distribution of extremes may always surprise us. That's not a flaw. That's what happens when scale outpaces narrative. James Webb is forcing us to accept that cosmology may be less about forecasting and more about retrodiction, understanding how we got here by reconstructing a past that was busier, faster, and more creative than we imagined. And in that reconstruction, the universe's size keeps inflating, not as a number, but as a sense of excess capability. Capability is the key word. A universe with excess capability can host contradictions. It can tolerate mismatches. It can absorb revision after revision without collapsing into incoherence. Our models are catching up to that capability, slowly. Which is exactly what you'd expect if the universe had a head start. Now feel how this reframes the phrase, breaks our models. What's breaking is not physics. What's breaking is our assumption that the universe was conservative with its own potential. It wasn't. And that realization, once internalized, doesn't just apply to the early universe. It applies everywhere. When we detect massive black holes earlier than expected, when we find star formation peaking sooner than predicted, when we observe large-scale structures that strain simulations, these are not isolated anomalies. They are echoes of the same pattern. The universe does not wait for our comfort. It moves at the pace allowed by its laws, not by our expectations. James Webb is simply making that pace visible. Which brings us, inevitably, to the future, not as speculation, but as continuation. If the universe had the confidence to build early, it likely has the confidence to let go later. Expansion accelerates, galaxies drift apart, information becomes inaccessible. This is not loss in a tragic sense. It's completion of a phase, and we live near the end of the phase where the universe is both large and legible. That is not frightening. It is precious. Because it means our moment, this brief window where ancient light still reaches us, where early structures can still be studied, where the universe's ambition is still visible, is not guaranteed. James Webb exists because we arrived during that window, and that fact alone reshapes the emotional weight of its discoveries. We are not just learning about the universe's size, we are learning about our timing. We arrived after the universe built its foundations, but before expansion erased the evidence. That positioning is not central. It is fortunate, and fortune does not require the universe to care. It only requires it to be large enough, old enough, and stable enough for observers to arise somewhere along the way. James Webb is showing us that the universe met those requirements easily, perhaps too easily. Which is why every new image, every early galaxy, every overgrown structure doesn't feel like a challenge. It feels like confirmation. Confirmation that the universe has always been more than our stories, and that the true size of the universe is not something we will ever finish measuring. It is something we will keep rediscovering. Each time our tools improve, each time our confidence resets, each time we realize the room has more depth than we accounted for. That's not failure. That's the correct relationship between a finite observer and a system that never promised to be manageable. And James Webb, silently orbiting far from Earth, staring into ancient darkness, is not overwhelmed by that relationship. It's thriving in it, because it was built for a universe that doesn't apologize for its scale. And now, so are we. And thriving changes the final assumption we haven't yet dismantled, the idea that scale must eventually plateau. That at some point, the universe stops surprising us not because we understand it, but because there is simply nothing left to be surprised by. James Webb is eroding that assumption quietly, methodically, because what it's revealing is not a universe approaching completion, but one whose early excess sets a precedent that echoes forward long after the conditions that created it have passed. Early galaxies forming fast is not just a historical curiosity, it's a signal about the universe's baseline behavior. When given freedom, it builds. When allowed time, it multiplies outcomes. When constraints loosen, it doesn't hesitate, it fills the space. That behavior doesn't need to repeat identically to matter. It defines character, and character persists. So when we ask whether the universe's true size has been measured, what we're really asking is whether we've encountered the ceiling of its behavior. Webb suggests we haven't even brushed it. Think again of how scale manifests in systems we know. A forest doesn't reveal its true size when you count trees. It reveals it when you notice how many species coexist, how many microclimates exist under the canopy, how many life cycles overlap without cancelling each other out. Diversity is scale made visible. James Webb is showing us diversity in the early universe. Diversity of galaxy masses, morphologies, star formation histories, all compressed into a window of time we assumed was uniform. Uniformity was our projection. Reality was already branching. That branching implies a universe that does not funnel toward a single outcome. It fans out. And fanning out requires room. This is where the narrative tightens towards something that feels almost inevitable. The universe's true size may not be representable as a single number at all. Not because it's unknowable, but because it's multidimensional. Spatial extent, temporal depth, structural density, outcome diversity, historical layering. Each is a dimension of size. Webb has expanded several of them at once. And expanding dimensions don't cancel each other, they compound. That compounding is why the phrase breaks our models keeps resonating even when technically the equations remain intact. Our models were built to manage a universe that expands politely along one axis at a time. The real universe appears to expand along many. Now slow your attention, because we're approaching the point where escalation becomes resolution, not by answering everything, but by settling the emotional account. The account we've been carrying is this: are we small because the universe is large? Or are we small because we misunderstood what largeness means? Webb suggests the second. We mistook sparsity for scale. We mistook quiet for emptiness. We mistook our observational limits for cosmic limits. And those mistakes were understandable. They were the best we could do with the tools we had. But now the tools have changed. And with them, the emotional posture required to face the universe has changed too. We don't need to brace ourselves against insignificance. We need to adjust to abundance. Abundance of history. Abundance of structure. Abundance of outcomes that do not converge on us, but do not erase us either. Abundance reframes humility. Humility is not shrinking oneself. It's placing oneself accurately. James Webb is helping us place ourselves. Not at the centre, not at the edge, but somewhere inside a system that had already done an extraordinary amount of work before our story ever began. And that work didn't exhaust it. It set a tempo. Now here is the final quiet pivot this message needs to land on. A universe that starts strong does not need to rush its ending. The acceleration of expansion, the long drift toward isolation and darkness, is often framed as a loss of opportunity, a universe becoming colder, emptier, less interesting. But in a universe that front-loaded complexity, late-time quiet is not deprivation. It's aftermath. Aftermath is not absence. It's trace. Every photon Webb captures is a trace. Every early galaxy is a residue of a universe that did not wait to become interesting. And that residue is thick. Thicker than we thought. Which means the future universe, even as it becomes observationally quieter, will still be standing on an enormous archive of past complexity. Much of it inaccessible, but none of it erased. The universe does not forget. It just outpaces us. That realization should not feel tragic. It should feel clarifying. Because it tells us that meaning in a large universe does not come from permanence. It comes from participation. We participate by observing, by modelling, by noticing when reality exceeds the boundaries we built for it. James Webb is participation made mechanical. It is a machine designed to look past comfort and report what it finds, honestly. And what it keeps finding is not a universe on the edge of its capabilities. It finds one comfortably inside. Which brings us to the kind of closure that doesn't shut doors. It widens perspective. The universe's true size is not something James Webb measured in kilometres or light years. It measured it in surplus. Surplus of early structure. Surplus of capacity. Surplus of outcomes. Surplus of history. And surplus is the one thing that, once revealed, cannot be unseen. We will refine masses. We will adjust timelines. We will debate dust corrections and feedback mechanisms. All of that will happen, but none of it will put the universe back into a smaller emotional container. That container is gone, because we now know something irreversible. When the universe was given the chance to build early, it didn't hesitate. It built fast. It built big. And it kept building long enough for us to notice. Which means the universe we are inside is not just larger than we thought. It is more confident than we assumed. And confidence, once recognized, changes how you interpret everything that comes next. Not as threat, not as anomaly, but as continuation. The universe did not reveal its true size to humble us. It revealed it because we finally built eyes capable of seeing what had always been there. And now that we've seen it, there is no smaller story to return to. Only a larger one to continue walking through. Together, briefly, aware, and still very much included. Inclusion changes the final pressure point, because once you accept that you belong inside a system this large, the question stops being whether you matter and becomes how attention moves inside scale. Attention is not evenly distributed, not in humans, not in galaxies, not in the universe. Scale doesn't flatten experience, it channels it. James Webb is not watching the universe everywhere. It is staring into carefully chosen darkness, deep fields where the absence of nearby light allows ancient structure to emerge. Those images feel overwhelming not because they show everything, but because they show enough. Enough to break the illusion that we were close to the bottom of the well. Enough to show that what we called deep was still shallow. This is important because it reminds us that even in a universe with excess capacity, perspective still matters. Where you look determines what story becomes visible, and we have only just learned how to look properly. For decades, we stared at the universe in visible light, like trying to understand a city by daylight alone. Webb shifted us into infrared, into heat, into dust-penetrated glow, into wavelengths stretched by expansion itself. And the city didn't disappear. It revealed older neighbourhoods, older than we thought. This is the part that feels almost intimate. The universe wasn't hiding. We just didn't have the right senses. And that's a humbling realisation, not because it shrinks us, but because it repositions responsibility. The universe didn't fail to be legible. We failed to ask in the right language. Now that we are asking differently, the universe is responding, not with resistance, but with generosity. Galaxy after galaxy, structure after structure, quietly waiting in ancient light. That generosity reframes what true size emotionally means. The universe is not an adversary withholding information. It is a system that requires patience, precision, and humility to listen to. James Webb is not forcing answers out of it. It is tuning in. And what it's hearing is a universe that has always been louder than we assumed, just speaking at frequencies we couldn't detect. Now slow down here, because we are approaching the deepest human consequence of this entire arc. If the universe has more capacity than expected, if it built early, diversified quickly, tolerated variation, and absorbed loss without collapse, then our fear of cosmic meaninglessness is misdirected. Meaninglessness comes from absence. This universe is not absent. It is abundant. The challenge is not finding meaning in emptiness. The challenge is navigating meaning inside abundance without demanding centrality. That's a different skill, and it's one we are only beginning to learn. James Webb is not asking us to surrender significance. It's asking us to relocate it. From being special because we are rare, to being special because we are aware. Awareness in a system this large is not automatic. Most matter never achieves it. Most structures never reflect. Most histories never observe themselves. We do. Briefly, locally, imperfectly, but enough. And that enough is the quiet miracle that doesn't get diminished by scale. It gets sharpened by it. Now consider how different this feels from older cosmic narratives. We used to oscillate between two extremes. Either the universe was made for us, or it didn't care at all. Webb is offering a third posture. The universe doesn't care about us individually, but it produces conditions where care can arise. That's not design. That's capacity. And capacity is what we've been tracing this entire time. From early galaxies that formed too fast, to structures that matured too soon, to expansion that refuses to slow, to a present moment where the universe is both fast and readable. All of these point to a single underlying trait. The universe does not operate near minimum requirements. It operates with margin. Margin is why early mistakes didn't doom structure. Margin is why uneven growth didn't collapse into chaos. Margin is why observers could arise late and still reconstruct the past. Margin is size expressed as forgiveness. And forgiveness at cosmic scale is what allows stories like ours to exist without burdening the whole. Now feel the emotional resolution beginning to settle. Not as an answer, but as alignment. We are aligned with a universe that is not fragile, not minimal, not barely holding together. We are aligned with one that had room to spare from the start. James Webb did not reveal the universe's true size by pushing against its edges. It revealed it by showing us how much happened before we arrived. And that realization carries a final, grounding implication. If the universe was capable of all this without us, then our role is not to justify it. Our role is to witness it. Witnessing is not passive. It requires tools, curiosity, discipline, the willingness to revise stories when evidence demands it. James Webb embodies that willingness. It doesn't argue. It doesn't insist. It shows. And what it's showing us is a universe that does not shrink when examined closely. It expands, not just outward, but inward, into our understanding, our expectations, our emotional capacity to hold scale without collapsing into insignificance or arrogance. This is the kind of expansion that doesn't need to be measured. It needs to be felt. And once felt, it doesn't fade. It becomes the background hum of how you think about reality. You stop asking whether the universe is too big. You start asking how you learned to think it was small. And in that shift, something stabilizes. Not answers. Perspective. We are not lost inside the universe. We are positioned inside it. Positioned at a moment when its early ambition is still visible. Its later quiet hasn't yet erased the evidence, and its scale can still be emotionally integrated rather than abstracted away. That moment is temporary, but it's real. James Webb exists because we are inside it, and it is using that fleeting alignment to deliver a message that doesn't shout, doesn't threaten, doesn't condescend. The universe did not miscalculate its size. We miscalculated our expectations, and now that correction has been made. The story does not end. It finally fits. Fitting changes how tension resolves. Because when a story finally fits its scale, it doesn't need to keep proving itself. It can slow down without collapsing. It can widen without fragmenting. And that's where we are now, inside a universe that no longer feels like it's trying to surprise us, but like it's allowing itself to be recognized. Recognition is different from discovery. Discovery is abrupt. Recognition is cumulative. It's what happens when enough small revelations align that resistance becomes unnecessary. James Webb didn't shout, "The universe is bigger than you think." It let the universe say it, repeatedly, calmly, through ancient light. Galaxy after galaxy, each one a quiet confirmation that early reality was not tentative, that the universe did not tiptoe into existence, that it arrived with confidence, built aggressively, and never apologized for its ambition. Once you absorb that, the final emotional shift becomes possible. We stop needing the universe to explain itself. We stop asking it to justify its size. We stop expecting restraint. And in that release, something subtle but profound happens. Scale becomes background instead of threat. When scale is background, meaning doesn't evaporate. It clarifies. Think of standing under a night sky far from cities. At first, the darkness feels overwhelming. Then your eyes adjust, stars separate, patterns emerge. The vastness doesn't go away, but it stops pressing against your chest. James Webb is giving us that adjustment period on a civilizational scale. The universe didn't suddenly become larger. We simply stopped insisting it be smaller. Now, let's bring the entire arc into a final, steady alignment, not by summarizing, but by letting the implications settle into a single, coherent posture. The universe's true size is not an answer. It's a condition. A condition defined by excess capacity, early decisiveness, tolerance for variation, and indifference to narrative convenience. A universe like that does not need to rush. It does not need to optimize for observers. It does not need to resolve itself cleanly. It simply continues. And within that continuation, observers arise, not because they are demanded, but because they are permitted. That permission is the quiet miracle we keep circling. Not a miracle of improbability, but a miracle of room. Room for galaxies to form early. Room for structures to mature fast. room for complexity to retry itself across billions of years, room for a small planet to develop chemistry curious enough to build instruments that can look back and realize the room was always there. James Webb is one of those instruments. Not heroic, not mystical, just adequate. Adequate enough to pierce dust, capture infrared whispers, and reveal that our cosmic childhood assumptions were shaped by limited senses, not by reality's restraint. And here's the final stabilizing truth that lands when everything else stops spinning. The universe did not outgrow us. We grew into it. Our models, our intuitions, our emotional containers, those were the things that were too small. Not the universe, which means there is no betrayal here, no collapse of meaning, no need to retreat into abstraction or nihilism. There is only expansion of context. Context in which our brief existence is neither central nor absurd. Context in which awareness is rare enough to matter locally, but not so rare that it threatens the whole. Context in which learning the universe is larger than expected does not diminish us. It relieves us of unrealistic expectations. We do not need to be the point. We get to be participants. Participants in noticing. Participants in revising. Participants in holding awe without demanding ownership. That posture is sustainable. And sustainability matters, because the universe will continue long after this moment of alignment passes. There will be times when much of what Webb can see is no longer visible. There will be observers in the far future who infer a smaller universe, not because it is smaller, but because the light has thinned. They will build stories that fit their horizons, and those stories will be understandable, just incomplete. We are lucky, not special, but lucky to live before that narrowing. Lucky to stand inside a window where the universe's early ambition still leaves traces. Lucky to build eyes capable of catching those traces. James Webb exists at the intersection of that luck and that capacity. And what it has shown us, finally, is something that doesn't need escalation anymore. The universe is not delicately balanced on the edge of collapse or meaninglessness. It is comfortably large. Large enough to surprise us repeatedly. Large enough to absorb our corrections. Large enough to include us without needing us. And once that truth settles, not as an idea, but as a felt background, the story stops feeling unfinished. Not because all questions are answered, but because the emotional contract has been fulfilled. We are not lost in a universe too big to care. We are present in a universe too big to panic. That difference is everything. James Webb didn't measure the universe's true size in numbers. It measured it in confidence. And in doing so, it gave us permission to stand inside that confidence, without shrinking ourselves or inflating our importance. Just standing, looking, witnessing. Satisfied enough to share the feeling, even if the details blur, because what stays is not a fact, but a sensation. The universe has always had room, and now, finally, we know how to feel that room without flinching. Now we let it land, not with a twist, not with a revelation stacked on top of another, but with a settling, like dust after a long fall, like ripples flattening after something immense has already passed through. Because the universe does not need a climax. It already had one. What James Webb has given us is not an ending to a mystery, but an ending to a misunderstanding. We misunderstood what kind of universe we were in. We thought it was cautious. It was decisive. We thought it was sparse. It was dense with action. We thought it grew slowly into importance. It arrived already capable. And once that misunderstanding dissolves, the emotional tension that's been pulling through this entire journey finally releases. The universe is not bigger than we can emotionally tolerate. We were just trying to tolerate it with the wrong posture. The correct posture is not defense. It's inclusion. We are inside a universe that does not strain under its own scale. A universe that has always had margin. Margin in time. Margin in space. Margin in outcomes. A universe like that does not produce meaning by focusing everything into a single point. It produces meaning by allowing many points to exist without conflict. We are one of them. Not because we were chosen, not because we are necessary, but because the universe is the kind of system where such points naturally arise. That is the final, stabilizing truth James Webb has made impossible to ignore. And it's why this story ends not with awe escalating into dizziness, but with awe settling into clarity. You are alive in a universe that was already old, already busy, already layered with history before your galaxy finished forming. That doesn't make your life insignificant. It makes it contextual. Context is what allows meaning to breathe. Meaning doesn't survive being placed at the center of everything. It survives by being placed accurately. James Webb didn't shrink us. It placed us. Placed us after the universe learned how to build, but before it forgot how to be seen. Placed us in a narrow window where ancient light still reaches us, where early ambition hasn't yet been erased by expansion, where the universe's true scale can still be inferred rather than guessed. That window will close. Not dramatically, not with an announcement, just gradually, as expansion carries information beyond reach. Future observers will live in a quieter universe, a dimmer one, a smaller looking one. Their stories will be different, but not truer. Because truth here is not about total access. It's about recognizing when access is partial and still meaningful. We have that recognition, and that's enough. The universe did not reveal its true size to intimidate us. It revealed it because we finally built tools capable of noticing what had always been the case. A universe that builds early. A universe that tolerates excess. A universe that does not panic about scale. A universe that does not ask permission to be large. And inside it, a species that briefly learned how to look back, feel the weight of what came before, and adjust its expectations accordingly. That adjustment is the real discovery. Not a number, not a boundary, not a rewritten equation, but a felt understanding. We are not standing at the edge of something fragile. We are standing inside something confident. Confident enough to have begun with abundance, confident enough to allow loss without collapse, confident enough to expand forever without worrying about witnesses. And yet, here we are. Witnesses, anyway. Not because the universe needed us, but because it had room for us. That is the idea a viewer carries away. That is the idea they can retell. That is the idea that survives compression into memory. The universe didn't turn out to be smaller or stranger or more broken than expected. It turned out to be more capable. And once you feel that, once that capability becomes the background hum of how you imagine reality, the fear drains away. What remains is not certainty. It's composure. We don't need the universe to end neatly. We don't need to see all of it. We don't need it to explain itself in human terms. We only need to recognize the kind of system we are inside. A system that began big, acted fast, and never stopped having room. James Webb didn't finish the story. It aligned us with it. And that alignment is complete. Not because there's nothing left to learn, but because we finally know how to stand inside what we're learning without needing it to shrink. That's the closure. Not answers. Perspective. Small enough to be human, large enough to belong. And satisfied, not because the universe fits in our hands, but because we finally let ourselves fit inside it.